Did anybody know? How many, are there bio papers up on Moodle?
Yeah, there are there.
How many are there? Okay. Alright. I'm not 100% certain, but kind of do want to give some time over to the child's exam. Yeah, maybe. It's interesting looking because from looking at the paper, I can tell what the exam writer thinks students know and don't know. So, for example, I can tell that the exam writer thinks that the students sitting the paper don't know about the remainder theorem. Because I can tell, because of the way they wrote the question, that they were expecting the student to do a long division to calculate the remainder. I could just tell from the way he wrote it. So, it means if you know the remainder theorem, then you can get the remainder much quicker than if you had to do long division. And it doesn't matter which way you get the remainder because it's a multiple choice exam. Also, I can kind of tell the exam writer doesn't expect a lot of students to know much about calculus. So, for example, the exam writer might ask you to find the vertex of a quadratic. Now, there's two ways to find it. You can complete the square or use the derivative. Which is easier? The derivative. You see, again, because it's multiple choice, it doesn't matter which way you get to the answer. Okay. So, anyways, these are the things we'll talk about. How to best use what you know to get the answers. Okay. They seem to allow calculators, but they seem to also design the questions in such a way that you don't actually need a calculator to figure out which one is right. But from previous years here, students are allowed to use a calculator. Now, I don't know how particular they'll be. I don't know. You know, they never seem to have a problem with the Casio calculator used here. I don't know if they'll look at that and say no. So they might object to it. Okay, binomial distribution. So the type of problem we want to have a look at now deals with events that have two possible outcomes. So example would be if you flip a coin, you can get heads or tails. If you vote on something, maybe you could vote yes or no. Okay. If you're looking at gender, maybe it could be male or female. You know, if you're looking at rain, maybe it could rain or not rain. So these are all examples of binomial, except with one difference. Usually with binomial, not usually, actually always with binomial, you have something that's repeated. So, for example, here maybe you flip a coin 5 times, or maybe here 1 million people vote, or maybe here you're looking at a class of 30, or maybe here you're looking over the space of a week. So with binomial, you have two parts to it. You have the event, which could be one of two possibilities, and the size, how many times you're looking at that event happening. Okay, so you have a size and you have a probability. So we'll use the letter P for probability, and we'll use N for size then. Okay, so let's have a look at an example, and then we'll have a look at trying to get a formula. Can I scroll down? Yeah? Scroll down. So, suppose I had a question like, you flip a fair coin, let's say, 5 times, and suppose you want to calculate the probability of getting 3 heads, and you don't care where it happens. You know, maybe it goes heads, 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 tails, tails, or tails, tails, heads, heads, heads. You don't actually care. You just care that you get 3 outcomes. So if you look at the possibilities, that means you're looking at probability of this, or, you know, it could be like this, okay, or oh man, I've already HT, H, etc., etc., etc. I'm not going to write all the possibilities out, but you get the idea. So let's calculate the first one. Heads, 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 tails, tails. Well, what's the probability of getting a heads? 1 over 2, and then another heads, and half and half and half. So the first one is 1 over 2 power 5, and then the next one 1 over 2 power 5, and this continues. So the real question then becomes, how many of these do we have? Because we can just multiply by how many we have. So the question then becomes, how many ways can you rearrange this? How many possible rearrangements are there here? So what do we think?
9.
Yeah, well, how would you calculate it? The C function.
To the power of 5.
It would be 5, choose 3. Yeah? You have 5 possibilities. You're choosing 3 here. But I mean, if you're not happy with that, how exactly am I getting this? You remember, you have 5 letters here, right? So how many ways can you rearrange 5 letters? If they were all different, A, B, C, D, E, how many ways can you rearrange that? Do you remember? 5 factorial. However, some of the letters are the same. 3 factorial. So you divide by 3 factorial, and also 2 factorial. But this is exactly 5C3. It's exactly 5C3. So this is 5C3 times 1 over 2 power 5. So with this example, we can kind of figure out a formula here. We won't bother calculating, let's just put it on the calculator. Oh, what is it? Thanks?
5 over 16.
5 over 16 is the chance here. Can I scroll down a little bit? So look, let's put down the formula. So you have n events, with probability P of success. So here, success might mean getting heads, it could mean vote yes, whatever the positive you want to call in your 2 outcomes. N events of probability P. And the question is, what is the probability of getting X successes, X right, X heads, X whatever it is, X successes? The formula is NCX. Now if you look back at our last example, that makes sense because the 5 and the 5 here was because there was 5 flips of the coin, and the 3 was because you wanted 3 heads. So it's NCX, and then it's P power X, because for example, if you take the first one, wait, P power X because it's success, 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 and then you want, in this case, 2 failures, so that's 1 minus P, which just so happens to also be a half. And the power is n minus x. That's how many failures you want. So this is x successes, and then the rest, n minus x, has to be failures. I'll give you an example here using this. Okay, so let's say you have 5 people are voting. And let's say the probability that one person, an individual, votes yes is 2 over 3. And my question is, what's the probability of getting 4 yeses from the 5 people? So using my rule, that would be 5C4, because I want 4 successes. 2/3, what power might I put here? 4. 4 successes, and then how many failures?
1.
If I want 4 yeses, that means how many no's? 1. So that's 1/3 power 1. This is the probability of getting 4 yeses, where you don't care about the order. You don't care who votes yes, you just care that you get 4 yeses.
Can't you just multiply by 4?
Multiply which by 4?
The probability of yes only.
Ah, that would give you a probability of 8 over 3, which who knows what that means. It means in 3 events it happens 8 times. Nice.
Oh.
Yeah. No, it doesn't make sense to do that, sorry. The probability goes over 1 if you do that. It doesn't work. Can you practice putting that in on the calculator? I recommend that you use brackets so that there's no errors. Let's see what you get.
80 over 243.
What's that as a decimal?
0.329.
So about 33%.
Yeah.
Well, they're not too difficult. Right? I'll give you another simpler one before we do a harder one. So let's say we have let's say you roll a die, and a win is if you get the 6, and a lose is everything else. Okay? And you roll a die, let's say, 3 times. And my question is, what's the probability that you win twice? And again, you don't care. It's binomial. You don't care if you win, lose, or lose, win. It doesn't matter. You just want to know that you win twice. Okay, so I'll just give you a minute with the calculator. See, can you calculate this? Got answers? What's that as a decimal?
0.04.
Why is it 1 over 2, not 1 over 6?
I don't know.
It is 1 over 6.
Yeah. Because the die has 6 sides.
That looks
Decimal.
oh, I think your power. No, your powers are wrong. Powers are wrong.
Decimal is
Yeah.
not 0.069.
Okay, let's calculate. So first, I need my C part. So what number goes up here?
2.
Up the top.
Yeah.
3.
C2.
C2.
Yeah.
You have 3 goals, and you want to win twice. Okay? Now, What's the probability on any individual go you win? 1 over 6. And how many wins here? 2. And then a lose? And how many loses? 1. So this is the answer here. About 7%, is it? About 7%. 7% chance you'd win twice. Yeah?
Yeah.
I saw some people had a little trouble with this one. Yeah. The 2 is because you have 2 wins, and the 1 because you have 1 loss. This is the probability that you win. You've got a 1 in 6 chance of getting a 6, and losing 5 in 6. And the 3C2 is because you have 3 goes and you want to win twice. Let's do another one. I'm going to keep it the same. I'm going to say the same game, except this time maybe you roll, let's say 5 times. And I'll make it a tiny bit different. I'll say, what's the probability that you win 4 or more times? Oh yeah, it was something.
It was
Yeah.
0.69.
0.069. Okay.
So 4 or 5.
Yeah, exactly, 4 or 5. Yeah. So I'm actually asking you to do 2 calculations here. So just to help you along, this is like me asking you that you win 4 times or you win 5 times. Now the answer should be pretty small. Okay, we're getting answers?
For the second one, the 5 over 6 to the power of 0, right?
Yeah, there'll be a power 0 in it. You have an answer, Daniel? What you get?
15 over 388.
Yeah, it's a pretty small number, isn't it? Yeah. So the first one would be 5C4, 1/6 power 4, 5/6 power 1. And then this one winning 5 times, 5C5, 1/6 power 5, 5/6 power 0. What did you say you got, Daniel? 13 over
15 over 3888.
3, like this?
Yeah.
It makes sense that it's quite small. Like if you think about it, if you roll a die 5 times, how likely is it that you'll get a 6 on 5 or more of those rolls? Not really likely. Yeah. Okay, let's have a look at another type. So example, 5 people vote, and the vote can be just a simple yes, no. And we'll say the probability that someone votes yes is, we'll keep it simple, it's 0.5. So 5 people are voting yes, no on a motion with probability 0.5. And my question then is, what's the probability that the motion will pass.
So yes.
Hmm? Say again?
So we take yes.
I'm not sure what your question is.
We take just yes without no.
Oh no, something. No.
What do you mean?
I know, I'm deliberately trying to let you think about it because in the exam sometimes you need to think about what the English means.
Well, it depends on what committee you're in. Some committees pass.
True. Simple majority.
So more than a half.
Correct, yeah. Correct, yeah.
51%.
Yeah. Simple majority. What do you call it if you need a 2/3 majority? Say again?
Is the majority?
Not sure.
A chair would say you need overwhelming
I think
majority
it's-
for the motion to pass, which means
No, but I think there's a term for it. I think it's like super majority or something for 2/3. Simple majority is at least half. So if you have 5 people, what does that mean? How many people have to, at least how many people have to vote yes? 3. But it can also pass if 4 people vote yes. Or 5 people, yeah. If you're coming from home countries that don't have democracies, I apologise for any confusion caused here. I realise all the votes pass with 100% certainty at some places at home. Possibly with more than 100% of people voting as well. It's always nice when that happens. Huh? Okay, you got an answer? Now, before you calculate the answer, it's good to have a rough idea in your head of what the answer might be. So if you think about it, you have 5 people and they're each evenly decided between voting yes or no. And you want to know what's the chances that it'll pass. So, to me, well, I don't know. To me, any answer that's close to 50% might be a reasonable answer. So, is it exactly 50%? It worked out exactly 50. I guess because everything's so symmetric here. So, the first one, 3 people, what would that be? 5C3, a half, 3, and then a half, 2. And then 4 people, 5C4, a half, 4, a half, 1, plus 5C5, a half, 5, a half, 0. But you actually realise all those are the same. So it totaled up to be a half. Yeah? Okay. So 2, 4, 8, 16, 32. You got like 16 over 32 or something, did you? Yeah. Okay. Continue? Yeah? But I'll give you the same, except this time I'm asking you the probability. What's the probability that you have at least 1 yes? So, what's the probability that somebody, at least one person, votes yes? You don't care how many people vote yes, you just want the probability at least someone votes yes.
So it's 1, 2, 3.
that's going to be long.
Can we just calculate the probability of voting all yes minus just take
You nearly have it, but you're not quite right. Think about that more.
Yeah, 1 minus
Yeah.
the probability of 5 yes and 1 and 0. No.
No.
5 no and 0 yes.
Yes, that's it, yeah. There's a short way to do this.
You already have half.
Yeah. Yeah, the opposite. This is equal to 1 minus the probability of not at least 1 yes. You know this basic rule. It's 1 minus the probability of the opposite. Okay? But what exactly does not at least 1 yes means? If you think about that sentence, not at least a yes. So that means 5 no's, which is another way of saying 0 yeses. So that's 1 minus 5C0, 1 over 5, 0, 1 over 5. Oh, sorry. 1 over 2, 0, 1 over 2, 5. So that's 31 over 32? That's an important example for the exam. It's a common little trick they sometimes do. In fact, they do it quite often in the exam, where they would ask you to calculate at least one of something happening, and and you look at it and it's only 2 marks, and you're thinking, but I have to do 1, 2, 3, 4, 5, and you realise, oh, it's 1 minus 0. Okay, so that's something that happens in the exam quite frequently. That example there. Yeah. Can I scroll down?
Sure, I got
Not yet.
1 over 52.
Yeah, but 1 minus 1 over.
Oh.
Okay. Okay, we'll do 2 more examples, but now we'll start to make it a little bit harder, a good bit harder actually. Both these examples you could get on the exam, but they would be, usually what happens is you have a probability question in section B, and it has multiple parts obviously. So the last part can sometimes be quite tricky. So that's the type I'll have a look at now. Can I scroll down? Yeah. So, what usually would happen is you might have some question where there's some experiment or some story going on. So, maybe it's something like you're doing some kind of experiment, let's say. It doesn't really matter what it is. Maybe you're testing if something's an acid or a base or whatever it is. So we'll keep it that. We'll say you're testing if something is an acid or a base, and you have 5 samples. 1, 2, 3, 4, 5. And let's say the probability that something is an acid, we'll just say it's for 5 over 6, we'll say. And then, of course, the opposite, the probability that it's a base, is 1 over 6. Okay? And let's say in this particular experiment you care if you get at least one of these results, or one let's say you cared if you want to get at least 4 of these to be an acid, to be a success. Okay, so if you get 4 acids as an example, or 5, we'll call that this is a success. So maybe put some words in here. We'll call these, I don't know, whatever they are, little strips of paper, and you have 5 on a tray. Okay, so the first question might be, what's the probability that you get at least 4 acids? We've seen a calculation like this before. In fact, I kept the numbers the same so you could use the same answer that you got, because I think this is the same numbers as you roll a dice 6 times and you want to get 4 wins. It's the same one as that. Okay, but my question's not going to be quite that, although you'll need to use that. So we'll say a tray success is when you get 4 or more assets. And now let's say I have 10 trays. Oh no, that's too big. 3 trays. And I want the probability of getting 1 tray success. So I'll just explain this again. You have a tray, it has 5 strips of paper on it. You consider the tray successful if you get at least 4 of those strips of paper to turn to an asset. Okay? You have 3 of these trays, and you want to know what's the probability that you get 1 of these trays as a success. Exactly 1 of these 3 to be a success. Now this is quite complicated. The reason it's complicated is because you have one binomial problem inside of another binomial problem. Okay? You have the 5 pieces of paper inside of one tray, but then you have 3 of these trays in their own separate problem. So I've seen this on the exam pretty much like this a couple of times. So I want to give you a minute to try and think about figuring it out before I give you the answer. Yeah.
How can the probability be over 6 when there's 5 selected subjects?
No, but each strip of paper has a 5/6 chance of turning acid.
Okay.
So whatever you're dipping it into, there's a 5 out of 6 chance that it turns to an acid. Well, what you should first check is what's the probability that a tray will be a success. Yeah, I mean, this is a calculation you've done already in a previous example.
Do they tell you that the probability of it being the base is the success?
Of being an acid. Of being 4 or more acids. What do you ask me?
Okay, so you're saying that the success is the 1/6, the base, yeah?
No, the acid. I said a tray is successful if 4 of the strips at least 4 turn into acid when you test them. That is what makes a tray successful. I want to know what's the probability if you have 3 trays, 1 of them successful. I'll have to calculate it. Got an answer? Different answers are good. Right, let's look. So look, first just concentrate on the fact that you have 3 trays and you want the probability of 1 of the 3 to be a success. So using the binomial formula, what would that be? 3C1 P, whatever the probability of a successful tray is, 1, and then 1 minus P, 2. problem is you don't know how likely it is for a tray to be successful just yet, so we need to calculate that as a separate problem. So let's calculate the P. So what makes a tray successful, I said, if you get 4 acids? Or 5? Well, there's only 5 strips, so if you got 6 acids, you've done something wrong in your experiment. So, what's the probability of getting 4 acids? Again, that's another binomial. So that's 5C4, 5, 6, 4, 1, 6, 1. Or 5C5, 5, 6, 5, 1, 6, 0. So you can feed that answer back into the previous line to get the final answer here. Now this one here you've already calculated. It was the same answer as the example with the dice I did earlier. What was that, by the way? Oh yeah, 13 over 3, 8, 8, 8. If you put that back into this, that's 3 times 13 over 3, 8, 8, 8 over 1 minus 13 over 3, 8, 8, 8 squared. So what did that work out as, please? Negative. So it's about 1%, is it? Nearly 1%. It's a little bit short of 1%. It's tricky, but that was a question I saw on the I've seen on the exam a couple of times. Yeah, I think the last time I saw it, they were saying, you know, a biology student has a tray of 5 containers, and each container contains a seed, and the chance that the seed will grow is whatever, 4 out of 5. You know, same idea. Okay. One more example. I think this will be the hardest one. Okay. So you roll a die again, and a win, again, we'll keep it the same, is if you get a 6. Okay. And you keep rolling until you get a 6. So my question is, let's see, what's the probability that you win 3 times and the third win happens on the 5th roll? So just to be clear, what you're doing here is you're rolling a dice. You get a win, maybe you get a lose, maybe you get a lose, you get a win. Your third win happens the 5th time you throw. So you know how big this size is. It's at most what? It's at most 5, because you stop when you roll your third win on the 5th attempt. So again, this one's the hardest one. I'll give you a minute to think about it. It's very, very tricky. The only hint I'll give you is it might be helpful to think about your wins as like to visualize it. So the hint I'll give you is, you know for a fact you want the third win to happen here. Okay, I think I've given you enough of a hint. You can think about it now. Yeah, now you can think about it.
So the first 2 wins are normal, and the third one comes in the 5th row, yeah?
Yeah, no, I'll try and work it out. Okay, let's have a look. I think some of you might have copped the idea here. Actually, this is two problems. First, it's the normal binomial problem. You don't actually care where you win. What do you care about here in these first four rows? You only, yeah, very good. You only care that you win twice. But you don't care where that happens. So, you know, it could be win-win, lose-lose. You don't really care. So what type of problem is that? That's the binomial. So, yeah, very good. 4c2, 1/6 squared, 5/6 squared.
6 to 5.
Yeah. Now, what about this go? How do we deal with this? Yeah, but how do I combine that with this? No. Times. Because there's an and here. So, times 1/6. Because what you're saying is, what is the probability I will win 2 from 4 and then get a win?
I got 6 to 5 over 2 3 3.
For this final answer.
Yeah.
6 to 5 over 2.
90? Oh, okay, that's better. Hmm? 1.9%, different again. You're getting an answer, Mo? Did anyone else get 1.9%?
Yeah.
Yeah.
The reason it's quite small is because you've put a lot of restrictions on what you want. You want 3 wins. Not only do you want 3 wins, you want the third win to happen on the 5th go. And not only that, getting a win is quite unlikely to begin with because it's a 1 in 6 chance when you roll a die. So that's why it's quite small here, only 1.9% chance. Okay. Not that I want to calculate, but I just want you to practice a little bit here of changing the English into calculation. Okay, so we won't calculate it, but I just want to think about what the formula would be, what you would write down. So you have 11, no, there's 10 people plus you voting on something. And again, it's a simple majority, yes, no, you're voting on something. And again, we'll keep it simple. We'll say the probability that you vote yes is 1 over 2. So each person can vote yes or no.
Including yourself?
Not including you. So what you're doing is here, you're assuming that if the 10 other people voting, each person has a 50-50 chance of voting yes or no. Okay? Not including you. So there's 10 people and you're the 11th person and you enter this group. And you assume that the probability of getting of a person voting yes is 1 over 2. This is a reasonable assumption if you don't know anything about the 10 people. If you don't know which way they're going to vote, it's reasonable to say it's 50-50. Okay? My question is, I don't want you to calculate, I just want to think about what you would calculate. What's the probability that your vote counts? So we have to think about what that means here for the story.
You mean the tie? Or
And what's the probability that your vote matters? No? Much less than that, I'm sorry.
So the winning
Yeah, whether or not it matters if you vote or not. What's the probability that it does matter that you vote or not?
You have those key votes.
Exactly. That's the idea. So, how would you calculate that?
Means that 6 people said no and
No,
6 people.
not quite. No.
5 people said no and 5
Yeah.
people said yes.
Yeah, that's it.
Oh.
Your vote only matters
Can see.
if 5 people vote yes and 5 people vote no. Then you, as the 11th voter, you actually matter a great deal. But if 6 people vote yes, or 7 people vote yes, or whatever, then it doesn't really matter what you do or don't do. So your vote only matters if the other 10 people are split. So what would that be? That would be 10C, 5, a half 5, and a half 5. What's that? 0.25, which is 25%. Now that's actually pretty decent. There's a 25% chance that actually what you have to vote on, your vote matters. Let's see how well this goes as we make the group bigger. So, what about if you're joining a group of 20 people? What's the probability your vote matters in a group of 20 people? That would be 20C 10, 1 over 2, 10, 1 over 2, 10. What's that now, Ev? 18%. All right.
I think it's
18%? Are you sure? That's actually pretty good. All right. Let's up it to a group of 100 people. 100 choose, what would it be? 50. 1 over 2, 50. 1 over 2, 8%?
Yes.
That's actually, that's pretty good, isn't it? So even in a group of 100 people, you've got an 8% chance that your vote will actually mean something. I don't know if the calculator can do 1000 C500. Can it do 1000 C500 or does it crash? Let's have a look how far we could go. Yeah, okay. Yeah, you can't push it past 100. I'm actually surprised by that. I wouldn't have guessed 8%. In a group of 100 people, there's an 8% chance that your vote actually makes a difference. I think that's pretty high. You know, because you might feel like, oh, in a group of 100 people, there's only a 1% chance maybe that my vote makes a difference. It was actually an 8% chance. Okay, so just for the last 5 minutes, if you can try some of these. And like I said, they can be pretty difficult in the final part of the section B question in the exam. So, again, you really want to probably try all of these, except maybe the last one. Although the last one is quite interesting. You have to calculate if somebody could buy your vote, how much it's worth.
Throwing.
no, you got it.
Please don't be children, just do some maths.